Okay, welcome to this second day of JFocus. My name is Ivar Grimstad, and I'll do a talk on microservice patterns today, and I'll show the implementations done by Eclipse Microprofile. My day work is as a principal consultant at Cybercom in Sweden. I live in Malmö, so it's not that far away from here. These are my credentials. My Twitter is the easiest way to contact me. I'm a member of the Java community process in the executive committee there. I'm also the spec lead for the MVC specification. I'm involved in Jakarta EE working group at Eclipse Foundation as the EE4J PMC. I'm also promoting a lot of stuff with Microprofile. I'm an Apache NetBeans committer, and I run Java Forum in Malmö. So I'm pretty involved in the community, and as a result of this, I'm also a Java champion and an Oracle Groundbreaker ambassador. And I do have stickers. So if you want stickers on Jakarta EE or Microprofile, come up to the stage afterwards, or a question is a sticker. So let's see. Today's talk. I'll do first a very brief introduction, then I'll go through a set of patterns. I have 8 patterns prepared. The last one, I got the demo up and working just before breakfast this morning, so it's kind of exciting. And then I'll just sum up at the end. So Microprofile, who has heard of Microprofile? Okay, a lot of people. So Eclipse Microprofile. The easiest way to get information on that is microprofile.io. It's a collaboration between a lot of vendors that want to move Java Enterprise a little bit faster into the cloud-native space. So to add support for microservices and do that on top of Java EE, or with Java EE as a basis for that. And what they come up with, the latest version is Microprofile 2.1. It provides a lot of the 12-factor app or cloud-native support for microservices. And as you see at the bottom, it is based on CDI, JSON-P, JAX-RS, and JSON-B. So it's Java EE technologies on the bottom with these more microservice-oriented APIs on top. And I'll go through a bunch of these in the patterns. So I will demo Microprofile during the way, so you'll get a feel for what it is and the different stuff. So these patterns are the ones I'll go through. And I'll start with a couple of structural patterns, the architectural and service per container, externalized, before I dive into the more application-specific, such as configuration, health checks, and etc. And I've grabbed the patterns from microservices.io. This is an old figure. I noticed that yesterday, but it still fits the purpose. So this shows all the patterns and the relationships between them. And the patterns I'll start with going through are the ones, just the main pattern, microservice architectures, compare monoliths with microservice applications, and just touch into having one database per host and one service per host. And after that, I'll go into more patterns and show some code. So microservice architectures. So the problem statement here is, what is the application's deployments architecture? And if you talk about microservices, you usually first talk about monoliths. And monolithic architecture, there's nothing wrong about that. It serves the purpose well for that kind of applications. And it has served us well, and it probably will be monoliths in the future as well. And this is a super simple view of a monolithic application. If you complicate it a little bit, a monolith can still be perfectly nicely layered, have services, decoupled components, and everything that you put on a fancy words around it. But the important thing is that it's treated as one unit. So whenever you do some change somewhere in your application, some of the components are changing, you redeploy the entire stuff. And another common thing about monoliths is that you usually have a common data source. So when you do a change in your database schema, it probably will affect most of the components in the application, or at least you have to redeploy the entire thing. When we look at microservices, and this is also a super simple example, we have an application that calls a couple of services, service A, B, and C. And so we've taken the monolith and divided into smaller services. So rather than having all the components call each other, we call other services. We have an application which also can be a service. You can have service-to-service calls and et cetera. But in this simple case, it's just an application calling 3 services. And all these services can also be kind of complicated as the monolith. And they can be nicely layered and structured and components and everything, and have data sources. But the important thing is they don't share the data source. So you have one data source per service. And that opens up for flexibility to have different kinds of data sources as well. So you can have a SQL database where that makes sense, and you can have a document database where that makes sense, or a graph database, or whatever kind of NoSQL solution you prefer. But you don't have one common schema that affects all the components. So that was actually more or less 3 of the patterns: monoliths, microservices, and database per service. There will be more code in a minute. So the service per container, the problem statement there is, how are services packaged and deployed? And the traditional way of handling enterprise application is that you have a data center somewhere where somebody is administrating an application server. It can be a WebSphere or a WebLogic or a Wildfly or Glassfish or Payara or whatever, but somebody in the data center is administrating this application server. And you create your applications and services, and you deploy them into the application server. So this is kind of, you as a developer, you develop service A, you probably have a team around service A and the configuration and everything that comes with it, deploy it into the application server via the data center. And sooner or later, this probably will work fine in a while, but sooner or later, maybe service B will start having problems, consuming some memory or some I/O stuff, and maybe blow up and destroy something, and service A and B will also, or A and C will also get into trouble, and you have to restart the entire thing. So the standardized way of packaging Java EE applications is the thin WAR. And that is usually what you do when you deploy it into an application server. Another way that has become popular is to use the Uber jar or the fat jar. And that means you run your application as a java-jar and your application. So you package your application server into, or whatever you need to run your application into the jar file, and that's your runnable. Another way of doing this is to use a hollow jar. And that is a variant of the thin var and Uber jar. That means that you take your application server services thing that your application depends on in a jar, and you have your application code in the var as a thin var, and you can run it as java-jar, the hollow jar, and then the application var. And why do I mention these things? Well, if you look at the Uber jar example, to be able to run this as java-jar, you need some kind of hardware or virtual machine or something underneath with an operating system or parts of an operating system, and you need a JVM, and then you can run your Uber jar, because the Uber jar contains everything. In the hollow jar approach, you still have the same stack underneath up until the JVM. And then you add the jar as the microprofile container I've drawn in this picture, and you have your WAR file on top, which is the application. In the thin WAR approach, you have the same stack up until the JVM, but you also have the Java EE container. provide it for you. And you deploy your ThinWar into it. But there will be some differences which application server you run, so you probably have some kind of deployment script that does it. Some different folder structure you drop your WAR file into. And when you add Docker to this equation, you still have the same stack of same variants of applications. And when you add Docker to this, it takes everything from the parts of the operating system you need and up and packages in a container. And from the outside, it really doesn't matter because whatever you're using to manage your Docker containers, be it Kubernetes or any cloud environment or whatever you use for Docker, from the outside, it doesn't matter. It's just simply Docker run. And the thing to think about here is how thick is the stuff you change every time. Because in the UberJar example, even though you just change a little comma in your application code, you will be deploying megabytes of data, creating a new image with a thick layer that contains megabytes. In the hollow jar and the ThinWar approach, you will be only switching the stuff you change, because the other thing is layered in Docker. So I'll show a quick demo here. Let me see which one I had here. So I'll show you with Pyara Micro. And to show you the simple code I'll be using, and this is more or less the same code I will be using in all my demos. It's just a super simple hello world. And this one says it's a JAX-RS application. It doesn't have anything weird about it. It has one annotation I'll come back to later, or a couple of them I'll demo in the other patterns. But what it says is hello from Pyara Micro. And if I want to run this one, let me see here. So, okay, I'm in the wrong POM file. Let's go to the correct one. There we go. So I can use the Pyara Micro Maven plugin and just build my application as you would do with any. Go there. If I just say Maven clean package, it will create a ThinWar for me that I could use to deploy into a application server. So you see, I get the ThinWar here. What the Pyara Maven micro plugin gives me is that I can also build this as an UberJar. Let me see, type it. So if I activate the Pyara plugin, it will take the war and create an UberJar for me with the Pyara version that I'm using. So here I get I still have the war files that I can use in my Java EE application server, and I have a micro bundle jar which I can run from command line. And what I also can do is to create a Docker image with this one and using the hollow jar. And if I want to do that, the most convenient way is to pick a base image that already has the Pyara Micro jar for me. So what I do is just to put the WAR file into there. So what I do here is to put the WAR file into the Docker image and run it from there. So if I want to do that, Docker build, I can do that as well. From the same code base, I'm not touching it, just deploying it to different options. And it will run exactly in the same way, in all kinds of stuff. So it built my Docker image for me. So if I run the jar, the microbrundle jar, it will fire up Pyara for me. Okay, some exceptions there. I think I have the wrong Java version. Oh, I have to build it as well. There we go. I won't spend too much time for this, but as you see, I'm showing Pyara later as well. But here you can see I get all the ways of building it. But I'll show the jar version. So there we go. Localhost 8080. Hello. So it should say hello. Okay, it doesn't. So forget about this. That was one of the demos. I'll come back to it later and show it better in my next demo. I promise. So I'm just looking at the time. So what we've done is to look at some of the structural patterns. What we will do is to go on and look at the others like configuration, health checks, access token, and circuit breakers and tracing and etc. So let's look at externalized configuration. The problem statement there is how to enable a service to run in multiple environments without modification. And the configuration project for Eclipse Microprofile gives you support for this. And by default, you have support for putting your configuration in a configuration file in your application that is bundled with your application, which is suitable for developers when you run it on your laptop. But when you put it to a production environment, you don't want these properties to be valid. It could be database connections or passwords or whatever. So then you can, for example, set some environment variables in a Docker environment that you can run your integration tests or other tests there. And you can, in your production system, set some system properties, and they will override each other. So if you have system properties in your system, it will override everything else, and that will be what you get. So to demo this, I'll be using Helidon from Oracle and the microprofile config. Let's see if this demo goes better. So for the Helidon, it's the same Hello World application. But as you see, I'm using @config property, which is from microprofile config, and I'm saying hello, and I inject this place, and it says use the default world if nothing else is given to you, and then it says hello from Helidon. So I'll just build this one just to show that I'm not cheating. See. Tests are running. Okay, this one needs Java 9. So there we go. So while this is building, I'll show that the next step I'm going to do is to go into the microprofile config properties, and I'll configure this application. I won't save it now, but I'll do that as soon as I've started this one. So if I run this one, like this, it's no configurations at all. It's just the default value. So in localhost, it says hello world. Nothing weird there. So if I go in here and say, hey, we're in Stockholm, so I'll save this file here. And since it's bundled with my applications, I need to rebuild it. So now I've actually have configured it in the application bundle and say, this is Stockholm, this application is running in. And that is fine for my laptop. So I'm just checking that the configuration is actually working. So I'm starting it up. And it's up and running. And it says, hello, Stockholm. But say I now want to move it to production. And I want to be more specific. So I don't want to build it again. I just want to run it. But I'll give it some system properties. JFocus. And just start the application again. And now it has a system property. I'll spell it right, but you get the point. Let's see. There we go. So the next pattern is a health check API. And the problem statement there is how to detect a running service instance and unable to handle requests. And luckily, we have the Microprofile Health API to help us with that. And for this demo, I'm actually going to use Pyara again. So let's hope it works this time. It's definitely me if it doesn't work. So let's get out of there. So sorry about this. Oh, my computer is giving me a hard time here. Come on. I don't know what's happening here. So let's stop it. There you go. So if I go into I'll open another project here, which I have called Healthy Duke. And this one is exactly the same as the other. It has a hello world. I've also created a health resource here, which has the @health annotation. And you don't see anything. Has it gone away? Sorry about that. Now we can see, okay? Cool. So in this application, the hello resource is exactly the same as the other one, but I also have added a health endpoint. So I can have give it some kind of stuff I want to check, and I've annotated with @health. So what I do here is I'll just run it to see if it's already there. No, I don't have it. Clean package. So Microprofile comes with a default health. So whenever you hit a Microprofile application and /health, you will get a 200 if it's up or something else if it's not up, and it will just give you some basic information. But here you can actually add information on your own if you want to do some special checks. Healthy Duke. There we go. So it's up and running. And if I hit /health here, you'll see it says it's up and it's at Duke Rocks, which is my specialized message. So what I could do here is to not have this and run it without the health check, without any of my own. But I'll go to my demo again, to the slides again, and I'll just go on and I'll show it in the next demo because all the application servers has this anyway. So application metrics at pattern 5 is how to understand the behavior of an application and troubleshoot problems. And Microprofile metrics comes to the rescue there. To use the metrics, I'll be using the microprofile metrics API with Apache Tommy. So what I have here is a measured Duke application. It's exactly the same as all the others. It's a hello resource, but what I added is an @meter annotation. That's the only thing I've added to this one, apart from the others. So if I go to measure Duke, package Tommy exec, I'll build it with the Tommy main plugin, and I'll just run it very quickly here. And what the application metrics does is to create Prometheus metrics, or metrics that can be consumed by some other monitoring tools, such as Prometheus. So if I go to this one, I think it's called root. There we go. So this one starts up Tommy, which is an Apache project from Tommy Tribe. There we go. If I go to, I can show you the health check here. It comes default is just as up because I don't have any specialized health check here. If I go in and look at the metrics, you see I get a lot of metrics here, and I can filter it on the application. And you see I get the hello resource metrics here as well. And you see, I don't have any hits here. So if I go in and hit the localhost 8080 hello here, it says hello world. And if I go and refresh the metrics, you'll see that it has a hit of 1 here. So it does measure by just using this meter annotation. There are other metrics you can spread around the code and get pretty decent metrics that can be consumed by, for example, Prometheus. So circuit breaker. It's how to prevent a network service failure from cascading to other services. And circuit breakers, you know them from your home. If your dishwasher goes crazy, you don't want your house to burn or anything. So what you typically have is a circuit breaker that opens up so no current flows to that system, that part of your host. But the other things still work. So your food is still preserved in your fridge even though your dishwasher circuit goes. And it's the same with microservices. If one service is down, you don't want the entire application to go down. You just want to have it handle that something is not working, and discover when it's up again. And Hysterix is a well-known circuit breaker, and you also have the microprofile fault tolerance project. And for this one, I'll use a Thorntail from Red Hat and demo the fault tolerance support in microprofile. Let's stop this one. And we'll go to the tolerant Duke. This is also a super simple Hello World application. But it has some additional stuff here. And what I've added here is first a timeout. So it says if this execution of this endpoint or the method in this resource takes more than 3 seconds, I want a timeout exception. And I also added a circuit breaker and say that if I have 3 failures, 3 timeouts, then wait for 10 seconds until you allow some traffic. So these are the special circuit breaker stuff here. I'm doing it at the endpoint now. That's not very, typically you would do it somewhere in your application code where you call your service because it's client-side circuit breaker. Because I just want to demo it in the browser. That's why I do it in the endpoint. I also have a at fallback annotation. So if this method here has some problems, either a timeout or a circuit is open or something, I want a fallback handler to handle the stuff. And what it says is just to return, I'm sorry, I can't count right now. And to trigger this thing to happen, This is just a service that counts. And when count is less than 3, that means the 3 first times I hit this service, I want to sleep for 10 seconds, just to be sure that a timeout happens after 3. So I'll execute for 10 seconds, but after 3 it will time out. And after that, I just want to return the count. So from 4 and up, it will work. So to be able to test this, I'll just have to prepare my browser a little bit. So I'll go in here, and I want to have 4 browsers. So, and I want all of them to be on localhost hello. That's good. Let's see. So, because I want to hit these 4 times, and we want to see them time out. It's going to take like 3 seconds for each of them. So it's up and running. So the 3 first times I'm hitting this resource will take 10 seconds. That means it will time out after 3, and it should say I can't count because a timeout exception is happening. And the 4th time it's just going to count after 10 seconds. So if I hit this one, there you go. And it's going to take 3 seconds before it answered. But I'll just hit them in a row here. And you see it takes 3 seconds, 3 seconds, 3 seconds, and then it's up accepting traffic again. So that's circuit breakers. Let's look at security. So how to understand, OK, this is not the right one. OK, so you know about basic authentication. The thing here is how to secure, to know that the caller of a service is the caller you want, and it's allowed to do whatever you want it to do. So I'll just recap a couple of concepts. So for basic authentication is probably the most used stuff we do. We add an authorization header with the basic and basics for encoding. And it's just like this. And it's handling every request. And whenever you have this in your header, you're authenticated. So, and then we add OAuth here. And rather than having the authorization header saying basic something, we say the authorization header is bearer something else, which is a little bit more stronger encrypted, but still it's the same thing. It's in every request. So it's a password like basic. It's just bearer versus basic. So it's basically the same thing. Then you have the JSON Web Tokens, which is a little bit longer heading. It's still a authorization bearer and a token stuff here. But what's interesting in this one is that it has a little bit more information. It's divided by these small dots. So the purple one first is a header, and then you have some required fields, and then you have some custom stuff, and a signature at the end. So if we look at this token, it would typically be the first thing saying the header information about which kind of algorithm is used and what kind of token is this. And then it has some properties that you have to have, like the expirations and the IAT and stuff like that. And you can have some custom ones, like the username or the scopes or roles or something else that you want to have for your application, and add it there. And at the end, you have a digital signature, so nobody can tamper with this one without the signature being invalid. So this is a way of passing information to the service that, hey, I have this role, I'm allowed to do this. So to repeat, you have a header, which is base64 URL encoded, which gives you information about the token. Then you have the actual token, which is some standard and some custom entries. And then you have a binary signature at the end, just to verify that everything is OK. So to demo this, I'll use OpenLiberty from IBM. So in the Secure Duke, I'll just have to start another application in the background here. I'll tell you what that does. So I have the hello endpoint, which is similar to the other ones I've had here. But what I've added here is I've injected a JSON Web Token. And JSON Web Token is from the microprofile JWT specification. And what I'm doing here is from the JSON Web Token, I just print some stuff from it. I print the subject, the groups, and the issuer. And I'm also using the Java EE security at roles allowed here and saying that only users with the role admin is allowed to call this service. So here I hook into Java EE security without configuring anything, because I'm just saying, hey, use this token. And I'm lying a little bit because I have configured a little bit. But what I've configured is that I've given the Liberty the key store that the issuer is using. It would usually just pick it with the contract. It depends on how your security system is built up. If you distribute the public key or you can get it underneath. But here I've just for simplicity just added the key store to Liberty and configured it there. So saying that, hey, use this key store. And also saying, configuring Liberty to set up the JSON Web Token on incoming. But I don't say anything about the users. I don't say anything about the roles. I'm just saying, in my application, I say, hey, use admin. But nowhere in the configuration I've said anything to Liberty that there are anybody with any role called admin or any role at all. I'm just saying it here in the application. You have to be an administrator to call this endpoint. So it's super portable. And I can also use the microprofile config to configure and say that the issuer of the token should be Open Liberty. So I can use the microprofile config to configure this application as well. So I'll just run the application. Let me see here, where is my browser? There. Let's see, is it up and running? There you go. So let's 9080. So this one is running on Open Liberty from IBM. Let's go to the hello and see that. Oh, okay, no, it's on 6060. I have a different port. So here you see, I get it 401. Right? I'm not allowed to do this. And if I look in the log here, it says the microprofile JOT feature cannot perform authentication because a microprofile JOT token cannot be found in the request. Because I haven't added any token yet. So let's add a token. And I'll go in here and just add a header for a JSON Web Token that I happen to have here. And I do a request again, but still 401. So I can go in here and say, hey, the JSON Web Token is not valid because the expiration claim is not valid anymore, because this is an old one. It's from December last year. So the token isn't valid anymore, so I have to generate a new token. And to do that, you either, depending on how your system, if you log into Google or Facebook or whatever, but I have a simple application that is provided by the IBM guides that allows me to log in and generate a token. So what I have for login here is I can log in as Bob. I can do a login to my application. I'm getting a token. So I'll just update my request here with the new token. There. Save it. Go back and refresh the application, and it says, Duke says hello to Bob with role. He's both an admin and a user, and the token is issued by Open Liberty. But what if he wasn't an admin? Say that somebody else is logged in. And luckily, I have such a user. So if I log out here and log in with Alice, Alice is a user. So if I take Alice's token and log in and use that in the request here, like this, and refresh again, it will say, I get a 403 because you don't have the permission to do that because you're not an admin, you're a user. So it works pretty well with practically zero configuration to get it to work. So then there's the last demo I prepared, and this is the one I did this morning, distributed tracing. And this is, OK, this was the other one. This was the JSON Web Token, but how do you trace your services across services? And Zipkin is one example of where you can do that. So you can have your application report into Zipkin, and then you can trace the service calls. So to demo this, I'm using the open tracing. I'm still using Liberty. So what I'll do is I'll just stop this one there, and I'll start Zipkin on my computer. Stop this one so we won't conflict. So I'm starting Zipkin. Let's see where we got it. Localhost, I think is on 24. I can remember the port. Let's see, it's 9411. 11. There you go. So I have Zipkin here. I don't have anything reported in because I just started it. So if I look at my trace Duke application, there you go. So what I do here is that in the Hello World resource, I haven't done anything. It's just the hello stuff here. But if I want to trace this one, I can add the @traced annotation. For some reason, my IntelliJ is there. So I've added the open tracing traced annotation. So this is just the default. I can also programmatically do traces when I do stuff in the code. But here I'm just using the simple one. So if I go in here and package, just build it. Let me see. Okay, it's in there. There we go. So I'll just start it up. And I can go in and as soon as it's running, if my computer will work. So there it's up and running. So if I hit the endpoint, which is hello, say it says hello world. That's not very exciting. But if I go into Zipkin here and say find traces, you see it's reported in this call. Now this doesn't really give any much because it's just one call. But if I had called other services here, I would be able to follow that tracing in the Zipkin console. So you see, it's super simple to instrument your application. You don't have to do anything weird. It's just add the trace annotation wherever you want to trace your stuff, and it will show up in Zipkin or whatever other tool you're using for tracing. I'll show another cool thing when I'm still here, which is not covered by any of these patterns, but Microsoft also supports OpenAPI. So you get the endpoints documented for you without doing anything. And IBM has been so nice to actually add a UI on top of it. So you actually have a Swagger client here where you can do test out your stuff. So with that, I'm summing up. So you remember this one. And if you look at the different patterns, you see how well they are implemented by Microprofile. It's more and more of the patterns are implemented by Microprofile. So if you're doing microservices and are interested in these an easy way to get support for microservices on top of Java EE, Microprofile is definitely something you want to look at. So the patterns I've gone through today is briefly about microservice architecture, service per container, externalized configuration, health checks, application metrics, circuit breaks, access token, and distributed tracing. Microprofile.io is the way to go to get information about Microprofile. If you want to participate in a project and join it there, it's an Eclipse project, so that's where you find all the developer resources, the issue trackers, the GitHub repos. So go into eclipse.org and search for Microprofile, and you'll find it there. Adjacent to Microprofile, you have Jakarta EE, which is also an Eclipse project. So Jakarta.ee is the place to go if you want to find information about what's happening in Jakarta EE space. We also recently launched the Jakarta blogs.ee. So if you're blogging about Jakarta EE or want to read about Jakarta EE, that's where you go. You can link it from the Jakarta.ee site. If you want to have your blog listed there, it's instructions for how to do that. So to sum up the URLs, the slides will be made available after this talk. Microservices.io is where I found the patterns. The samples for this talk is on my GitHub. Microservices.io and Jakarta.ee are sites to go for more information. So that's what I had. Remember to vote in the app and give it a high score if you like it. And please tell if there's something you want to change. So with that, thank you for listening. It's been a pleasure, and enjoy the rest of the day.